Every molecule has London dispersion forces. These are caused by the constant motion of electrons. At any moment, the electron cloud can become uneven, creating a temporary dipole. That temporary dipole can induce a dipole in a nearby molecule, leading to attraction. The strength of London dispersion forces depends on the number of electrons. More electrons mean a larger, more polarizable electron cloud. Greater polarizability leads to stronger dispersion forces. Dipole forces occur between polar molecules. A polar molecule has a permanent dipole, meaning one end is partially positive and the other is partially negative. Opposite partial charges attract, creating dipole-dipole interactions. Hydrogen bonding is a stronger, specific type of dipole-dipole force. It occurs when hydrogen is directly bonded to nitrogen, oxygen, or fluorine. These highly electronegative atoms pull electron density toward themselves, making the hydrogen strongly partially positive. That hydrogen can then strongly attract a lone pair on nitrogen, oxygen, or fluorine of a nearby molecule. When an ionic compound dissolves in water, it dissociates because of ion-dipole attractions. Water is polar. The oxygen end is partially negative, and the hydrogen ends are partially positive. Cations are attracted to the oxygen side, and anions are attracted to the hydrogen side. These attractions can overcome the ionic bonds in the solid. In order of increasing strength, the intermolecular forces are London dispersion forces, dipole-dipole forces, hydrogen bonding, and ion-dipole forces. Now for the four main types of solids. Ionic solids are composed of positive and negative ions in a crystal lattice. They have high melting points, are hard and brittle, and conduct electricity only when molten or dissolved, because the ions are free to move. Metallic solids consist of metal cations in a sea of delocalized valence electrons. The mobile electrons explain why metals conduct electricity and heat. They are also malleable and ductile. Molecular solids are made of discrete molecules held together by intermolecular forces. Because these forces are relatively weak, molecular solids tend to have low melting points, are soft, and do not conduct electricity. Covalent network solids are made of a continuous network of covalent bonds. They have very high melting points, are extremely hard, and generally do not conduct electricity.